Okay, good afternoon, everyone. So we'll begin today's seminar. We're very pleased to have with us Don Fournier as our speaker today. My name is Nancy Holm. I'm the seminar organizer and assistant director here. Before we get started, I'd like to remind everyone to please silence your cell phones or pagers. Also, we'll be taking questions from the audience and from those listening online at the end of the seminar. So if you could hold your questions till then, I'll come around with the microphone, and that way we can record the questions also so everyone can hear those. For those online, you can type in your questions at any time, and then we'll answer those later on also. Today, this is our last seminar for our series on which is focused on sustainability planning. And all of the seminars are recorded and archived on our website with permission from the presenters. I think there was one where the presenter did not want his presentation online and available, but usually we have all of those up on the website. So I'm very pleased today to welcome Don Fournier, who currently is an energy consultant with the Illinois Association of County Board Members and Commissioners. He's working with Illinois Energy Now program for the public sector. He is retired from the University of Illinois, where many of you, I think, have known him before, where he was the manager director of CDAC, which is the Smart Energy Design and Assistance Center. He was there for a number of years, because prior to that he was also chair of the Building Research Council as well as managing CDAC. Don has his PhD in urban and regional planning from the U of I, his master's in mechanical engineering from the University of Massachusetts at Amherst, and his bachelor's degree is also from UMass in electrical and electronics engineering. So with that, I'd like us to please welcome Don Fournier.
Thank you, Nancy. Everybody hear me okay? Good. Today I'm going to talk about climate change and how that affects how we plan for sustainability. And it's really going to be focused on planning for climate change and what's involved in that. To start with, I'd like to talk a little bit about climate change. I'm sure we're all fairly familiar with this. I'd like to talk about a few facts I think that are interesting and to see how that fits into the planning scenario. So everybody, I'm sure, has seen these curves. We've been about a 100,000-year cycle between minimum glaciation and maximum glaciation, with an interglacial period of maybe around 20,000 years before the planet glaciates again. These cycles are caused by what we call Milankovitch cycles, the orbit of the planet around the sun and how that changes, the precession of the Earth around its axis, and then actually the change in the tilt. The 22,000-year cycle, a 41,000-year cycle, and about a 100,000-year cycle in there. And they kind of act like beating sinusoids, and we get cold, 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 warm, cold, 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 cold. Kind of the way it works. It's the way for me, is an easy way to look at that. So humanity been around. Well, we started right around here 200,000 years ago. 200,000 years ago. Out of Africa, maybe one migration 130,000 years ago, went all the way around, followed the shoreline around down into Australia. Second migration out of Africa, maybe 60,000 years ago, up in through Europe and around into Asia and spread all eventually maybe 13,000 years ago across to the Americas. So that's when the human came around. So have we been changing climate for how long? When did climate change start? Everybody says with the industrial age normally. Well, it turns out reality is when we look at the past 7 interglacial periods and plot carbon dioxide Okay, that's the bottom graph, and the standard deviation is the blue, and the top graph is methane. Here again, the blue line was the previous average of the previous 7 interglacial periods, and the previous 7 all came along smoothly. We hit a carbon peak fairly shortly into the interglacial period, and then carbon dropped from then on. Maybe some little fluctuations out there. Well, what happened about 7,000 years ago? This interglacial is different from the past 7. Carbon turned around and started going up. That is not a natural phenomenon. When we look at where the planet is and the orbits and the angles and all these things, we should be following the same path as all these other previous interglacials. So, what happened 7, 8, 9,000 years ago? The Neolithic Revolution, right? Agriculture, settled places, deforestation on a massive scale of the earth. That's when we turned around carbon. And we turned it back around from 260 parts per million up to, we sort of leveled off at 280 and kept it at that 280 level till the Industrial Revolution. And then, whoop, the curve goes. Methane. We followed fairly similar tracks from previous interglacials till about 4,000, 5,000 years ago. What happened 5,000 years ago? Any ideas? Cultivation of rice with rice paddies. Took over, came through, massive amounts of methane released. So these are the 2 primary climate change gases. We have been in control of climate for 5,000 to 9,000 years. We've been altering the climate of the earth. We're not getting cooler, we stabilized it. Okay? So human influence is certainly there and significant. And a lot of people like to say it's predominantly human influence. I say it's about 110% human influence, but I tend to be a radical. So, okay, the greenhouse gas concentrations in the atmosphere, all of them you can trace back to human intervention within the climate system. We've seen increased radiative forcing, we've seen observed warming, and we have a better understanding of time goes on of the climate system. It's unequivocal that we have met the enemy and they are us. Now, when I look at this, I always say, well, perhaps a little climate change seems to be a pretty good thing. If we can hold it at that 280 or 300 in that range and keep the Earth in a fairly temperate, moderate climate regime and avoid overall cooling in the future, maybe that's not such a bad thing. So, but this is the last 5 decades of measurements at Mauna Loa in Hawaii. As you can see, back in 1950, we were already up to about 315 parts per million of CO2 in the atmosphere, and we steadily moved on up to last year. We're right around 396 is the average. We've actually punched through the 400 ceiling in the cycle. As you notice that this curve is full of cycles, goes on all the way up. Well, that's the annual flow of what we call new carbon. That's the flux of new carbon on the Earth. What is new carbon? Here's a good example of new carbon. Okay? The leaves, the fruit, the farming, the agriculture sucks up carbon and then goes away as winter comes. The curves are predominated by the northern hemisphere. Why? That's where the land is on Earth. So that's where the fauna is, the flora is that has its impact. So a couple interesting things are going on. The cycles are actually getting a little larger, and they're shifting in time. The downturn, which means it was taking up carbon, is starting 4 days earlier, and it's going back up a few days later. That shows that we're expanding the temperate zone, and so that's an influence on climate there. And it's actually getting larger. We're trying to figure out why that is, and one thought is, well, increased carbon in the atmosphere does promote plant growth, so maybe a third of it is that, and I think the other third is just increased agricultural productivity around the Earth and continued deforestation. Now, old carbon. How do we know this is being pushed up by carbon? Well, I have a sample of old carbon here. I don't know how many of you get to deal with old carbon on a regular basis. That's Pennsylvania anthracite, 320 million years old, somewhere in that range, late Carboniferous period. That is, when we burn that, that thing is almost pure carbon, except for maybe 5 to 8% ash. The rest of it's carbon. The next stage of metamorphosis for that is graphite. So that's from Pennsylvania. So we can tell by the isotopic content of the atmosphere and how it's changing that it's old carbon that's pushing this curve up. So we know as a fact this is not a natural phenomenon. This is due to our burning of fossil fuels. No question. Our path for the last 4 decades or so, you can see the yellow is fossil fuel, CO2. The orange is from land use change, those types of things. Methane, okay, we're seeing more methane will increase production of rice, and I think we're starting to see more fugitive methane from fracking, natural gas production, and actually warming of the permafrost and some other things. I think we're starting to see a little bit of a positive feedback loop coming in. Okay, and then we have N2O, and that's from agriculture farming, and then the top of the F gases, that's from our refrigeration and air conditioning, loss of those gases out there. So that's kind of our picture now. When we look at where it's coming from sector-wise, about 57% of our CO2 is from fossil fuels, another 17, 18% from deforestation, biomass decay, etc. Methane, 14%. N2O, 8% roughly, and then the F gas is about 1%. Sector-wise, where do they come from? Well, energy supply. When you read energy supply, read electrical power sector. Pretty much, they're a massive carbon greenhouse gas producer. Transport, about 13%. This is worldwide. Residential, commercial buildings, about 8%. Industry, 19%. Agriculture, 14%. Forestry, 17%. Water and wastewater, about 3%. So it doesn't look bad, our built environment, our buildings, but when you take about 2/3 of this from electricity and put it into here, you find that our buildings are a pretty big piece of the action, too, as far as producing climate change gases. So kind of set the stage here. When we look at sustainability, we're all used to the, I call it the 3 meatballs. Here we got the social dimensions, the economic dimensions, and the ecological dimension, or people, planet, profits, however you want to look at this. This is our traditional look at sustainability. We want to enhance each one of these and make sure that not one is being degraded to favor the other. Well, the picture has changed a bit. Now we need to put this whole thing of sustainability within the concept of climate change and what's occurring on this level. And to do that, how we're going to respond to that, well, we really need to look at climate action planning. And most climate action planning lately has been towards a mitigation. We need to really start to think about adaptation, because we can stop emitting carbon tomorrow, and we still got 1,000 years of climate change in front of us that is going to impact the environment, our social systems, and our economic system. Today, we need adaptation. Look at the forest fires that are burning up the West. Look at the super typhoons and stuff we're getting in the Pacific. Those are all aspects of climate change. People ask me, well, what's going to happen with the West? I say it's going to dry up, burn up, and blow away. That's pretty much what we can look for the West Coast. We'll see. And a lot of, we're going to see how hurricanes turn. Our storms are having a much higher content of energy in them. When we do get hurricanes, they are averaging now 40% more energy. So you lean more towards the higher end of the scales with these storms. Same thing with our tornadoes we're starting to see. So mitigation and adaptation must be part of our look at climate. Look at sustainability. And so what we're seeing, we have a disaster risk management that we have to deal with now. These forest fires, flooding, these types of things. We have to link our adaptation plans to our development plans, so that social, economic dimension, we have to look at how we're developing and develop in a manner that adapts us to climate change. We need to look at the aggregate impacts for ecology and our economics. And I mentioned, the billions and billions of dollars each year as it's going up due to issues associated with climate and weather. We need to figure out how to sustainably manage our natural resources in a changing environment. For quite a while now, I've been thinking about, we spend all this effort with threatened and endangered species. And I said, well, in 100 years, that species is not going to live in that forest that we're working to preserve, because things are changing. So we need to think about these things when we look at our natural systems and how they're going to change as the climate changes, and how then we deal with endangered species and that type of thing. Implications for environmental quality is if we have ecological degradation due to climate, that's going to degrade our social dimension, and we need to enhance that adaptive capacity of our social structure. And I'll talk quite a bit about adaptation and what that's all about in a few minutes. So there's other things kind of orbiting around the outer circle, and these can be inadequate institutional capacity. I think we see this today, that we're not really ready to address these issues and to deal with them. Extreme hazards and events and black swans and these type of things, they come up and catch us and bite us. Unequal access to resources. It turns out there's probably going to be winners and losers in the climate game. Okay, the rich nations are going to be able to deal with these issues a lot more readily than the poor nations. So the poor nations are going to have real problems with climate change. And poverty. I heard a statistic the other day that just boggled my mind. 85 people, that's 85 people who fit in this room, own more resources than the lower 2.5 billion people on Earth. So poverty and inequity are also a big problem that's going to be exacerbated by these issues. So what do? We want to do some climate action planning. We want to look at mitigation and adaptation. They're two sides of the same coin. We shouldn't be doing just mitigation. We need to also be thinking about how we adapt to these changes that are coming down the line. Okay? And the approach, mitigation benefits the whole globe. We start producing greenhouse gas emissions. We reduce that CO2 in the atmosphere. The whole world benefits. Adaptation is local. It's like a lot of issues of sustainability. It's regional, it's local. What you do to adapt depends on what you're going to experience for climate change. So it's a local phenomenon. So mitigation is essentially focused on gathering information about what our emissions are and then figuring out ways to reduce those emissions. It's pretty straightforward. We want to reduce those drivers of climate change. And so we get through that by reducing our fossil fuel usage. We get to that by improving mileage of our cars. We do this by looking at how we change land use, how we do agriculture. Okay? And we can also look at the other half of that is can we enhance sinks? Can we enhance the Earth's ability to take up carbon from the atmosphere, which is another area that we need to deal with. So that's why we're paying Brazil, to stop cutting down the forests and things like that, because that's a major sink. We want to preserve the sinks where we can. Okay? So where we can look at mitigation aspects, the purple balls are outcomes. The square blue boxes are sort of the demands that create that outcome. So when we look at population, income, household size, consumer behavior preferences, our demands, it's our demands for goods and services. Okay? That's a place where we can intervene in here to reduce the demand for goods and services or alter the demands for goods and services. To provide those goods and services, we need to do production and delivery of services. So when we look at how we do that, well, that creates our demand for energy. If we can alter and be more efficient with those, then we can reduce the demand for energy. So, but we have an energy demand. So what's the carbon intensity of our energy that we provide? So that's another place where we can intervene, and because what we get from our demand times its carbon intensity gives us our emissions. And the last place we can look at it is post-emission carbon management. Can we do cap and trade? Can we do carbon capture and storage? Can we do things to clean it up after we've burned it? Those are the issues there. And when we do that, then our final result is that atmospheric concentration of carbon. So plenty of places to intervene in this cycle, and this is where mitigation comes in and hits all of these in different ways. So, but the current situation in the U.S. is a little muddled right now. Most greenhouse gases remain largely unregulated in the U.S. They discharge without penalty. The only ones that we're really controlling right now are some of the F gases, the hydrofluorocarbons, those types of things for refrigerants. We have the Montreal protocols, and we're right in the middle of a process now of updating those to take care of the HFCs. So that's a growing thing. EPA does have a new proposed clean power plan. I'll talk about that in a little more depth in a second. But there's no price on carbon. There's no regulatory pressure yet. There are few incentives to do anything about carbon. Now, we do have a couple of sectors of the nation where they're starting to look at this. Up in the Northeast, there's something called RGGI, the Regional Greenhouse Gas Initiative, which is New England and New York, and they actually do have a cap and trade program going on there. The West Coast is also looking at cap and trade. And at one time, there was actually a Midwest climate consortium made up of the Midwest states. That has died. Okay, we elected too many Republican governors, and they put that one away someplace. Okay. So we continue to lock in current technologies that are carbon intensive, processes that are carbon intensive, and so we have no incentive to change the way we think what we're doing, and so the bad stuff continues. Now, the new EPA proposed regulation is essentially a 30% reduction in the carbon intensity of the electrical power grid by 2030. Okay? They have goals for each state. Each state can set its own program to meet these goals within what we call 4 blocks. Okay? The state can also put a hard carbon number in if they want, but all said and done, when 2030 comes around, they're going to say how many megawatt hours did you generate in your grid and how many pounds of CO2 were produced, and they're going to divide the two, and they're going to come up with a number. Okay? For Illinois, that number has to be reduced from 1895 to 1271 pounds per megawatt hour, which is a 33% reduction. That's our state goal. Now, how are we going to meet that? Well, the 4 blocks are: 1, you can increase the efficiency of your power plants. You get more megawatts for the same amount of fuel going in. Number 2, you can change fuels of your power plants. We're going to see more pressure to shut down the coal plants, go with combined cycle gas turbines that can maybe be in the 60%, 65% efficiency range and burn natural gas. The 4th block is renewable. We can start doing more renewable energy. Now, Illinois does have a renewable energy standard. Our goal is 25% renewable by 2025. That's in state law. How we're going to meet that is 80% wind, 6% photovoltaics, and the other 12% biofuels or whatever other methods that you want to meet that thing. The 4th area is energy efficiency, energy conservation, improving how we use energy. We have major programs in the state now in that arena. Those are going to probably be expanded under this program. So we're going to continue doing these things over time. Now, this thing is out for comment right now. They've had, I think, 1.6 million comments on it. And, of course, half the states are threatening to sue and yada, yada, yada. But everybody seems to forget the issue of carbon has already been to the Supreme Court. And they have said, the EPA, you must regulate carbon. So I don't think it's going to get much of a reception at the Supreme Court again. We'll decide how this works. So this is going to start taking an effect in probably a couple of years. The states have a year to get their master plans together, and then they've got another couple of years to start implementing. And then there's some interim goals along the way up to 2030. So we'll see how this all plays out, but I look at it as a very positive thing if it comes to be. So, steps of a mitigation process. Remember, mitigation, we want to reduce our emissions. So you need to have a plan that you put together. So you want to collaborate with your stakeholders, draw in stakeholders, draw from the community. You want to develop and understand what your greenhouse emissions are, what your profile is. Many municipalities have done this. They belong to ICLEI, which is the, it's French, so it means Communities for Sustainability or something like that. Okay, but Urbana has a climate action plan. Champaign is batting around the edges of one. They're looking at the emissions. They're categorizing the emissions. Now, you've got to set some goals associated with those emissions. You want to do some reductions in those. How do you set those goals? Excuse me. And you want to identify, finalize what your actions will be to meet those goals. Set up a program, figure out how you're going to fund it, implement those actions, and then implement your program, and then track, measure, see how you're doing, maybe modify your program, evaluate your progress. So you got a plan, do, check. That circular process that makes for improvement as we go along. So this is the mitigation plan process. As I say, there are plans out there. Many municipalities have started into this process of mitigation. I think the university plan is basically around mitigation so far. So how do we measure carbon? How do we do it? Well, we break it up into what we call 3 scopes. Scope 1 is emissions that are directly owned by you. So it would be the boiler in this building. The emissions from the university would be Abbott Power Plant, these types of things. What we do, the cars that we own, what we own that emits greenhouse gases, that's your Scope 1 emission. Scope 2 is the emissions from the electricity that you buy, the grid emissions that belong to you because you bought that electricity. Then Scope 3 is your indirect emissions that result from your activities. So you fly on a jet plane, you have a contract for some supplies, you got embodied carbon in something you buy, you cause people to deliver things to you or they burn fuel to do that. Those are indirect emissions. Well, what I find in my own mind that these tend to be somebody else's Scope 1 emissions. And we don't want to get too confused about that. I think focus on Scope 1 and Scope 2, maybe bat around Scope 3 a little bit. So I just kind of discussed those. Anything you own is at Scope 1. Indirect is from the power plant, and then indirect, such as travel, contracts, waste disposal, those types of things are your Scope 3 emissions. So you want to track those, find out what those are, and then establish goals associated with those. And ICLEI, which is Local Governments for Sustainability, do have protocols out there. They've developed protocols. They have a community program protocol. They have a local government protocol. The World Resources Institute has a protocol for businesses. So everybody can get on board. The internet is awash with protocols and guidance on how to do these things. And EPA has something called eGrid, which is how you can look up what your indirect emissions from the grid are. You can see how many kilowatt hours you use, and then based on your region, what your carbon footprint is for that. So, but the take-home message here is we need to kind of rapidly get along with these programs. We need to deploy low-carbon energy resources. We need to get much more efficient. We also need to enhance our natural sinks of carbon. Those are musts. And there is a pretty adequate portfolio already existing out there that we can take advantage of. This isn't rocket science, a lot of it. This is pretty standard stuff that we are doing and can do and should do more of. But no one technology is going to be able to do the whole job. We need to have a lot of new science and use a variety of strategies. It has to be an all-the-above approach to reducing our emissions. And everything has impacts and costs associated with it. So, but many of these can be self-compensating. Many things you can do to reduce your energy consumption actually turns a profit. So you can save money. So, things we can do for near term, we increase our energy efficiency and Buy a car that gets better mileage. Put a furnace in your house that's 98% efficient, not 80% efficient. Put an air conditioner in your house that's CO20 and not CO13. So all of these things will reduce your demand for energy and therefore reduce your emissions footprint. We need to accelerate the use of nuclear power and the use of renewables. We also need to think about carbon capture and storage. We need to get a move on that. Now in this country, everybody familiar with FutureGen? Heard of FutureGen? FutureGen 1 was you would take coal, make natural gas out of it, strip the carbon off, sequester that in the ground, then run a gas turbine with the hydrogen that you got. So that was not going to be built in Texas, so it got the axe. Okay, you got to remember who was president then. Okay, that was a few years ago. FutureGen 2 is under construction right now. It's a plant up in farther north in Illinois. I want to say Meredosia. Yeah, I always think Mendota, but that's not it. Meredosia. There's a plant, and what that's going to be is what we call oxy-combustion. They're going to burn coal, but they're not going to burn coal in air. They're going to burn coal in oxygen. So when you take that carbon and mix it with oxygen, you don't have all that nitrogen coming out of the smokestack. You got a pretty solid stream of CO2. You can capture that CO2, compress it, liquefy it, put it in a pipeline, send it down at Tuscola and inject it into the ground. That's FutureGen 2, and that's under construction right now. By the way, China is building 14 FutureGen 1s. Okay, so we've lost the technology and we've lost the world advantage of doing that technology first. So these are things that we can do. Accelerate the retirement of these coal-fired power plants. Hopefully, the new EPA regulations will do that. We want to replace them with less intensive emitters of carbon. And adopt new technologies. We really need to push the new technology window. Now, this is a graph from McKinsey and Company, and what they show is things you can do to reduce your carbon emissions. The ones below the line over here, they're things that you do at a profit. Ones above the line are things that are going to cost us as a society to do. So we can get about halfway there at a profit. So why aren't we doing this? Well, we're trying to do this now. This is things like improving HVAC systems, residential appliances, tillage and residue management on agriculture, cropland nutrient management, efficiency improvements in industry, small hydro, geothermal, LED lighting, all these things that we can come in, biofuels, hybrid cars, plug-in cars, all these things are part of that mix. We get over here and we're starting to look at reforestation, afforestation, solar power, carbon capture and storage. Those things are going to cost money. They also cost energy, which means more money. So, but we can get halfway there at a profit. So we need to kind of push on with that. So, but innovation is required. We really need to start using the newest technologies in our built environment. We need to have new systems and develop new energy systems. And we're going to have new institutional, economic, social policies that push us in that direction. We need to foster this widespread adoption of new technologies. Last summer, I put in my home, I put in a 97% efficient furnace, a 98% efficient water heater, and a CR20 air conditioner. That cost me 3 arms and 2 legs, but I did it, you know. But I have 2 hybrid cars. I'm in the process of converting all my lighting in my home to LED. So those are things that you can personally do to reduce your carbon footprint. And you know, eventually we have to get everybody in the same mode to do those things, and then we can have a significant impact on all these things. So it can be done, but it takes all of us. The other shoe I want to drop is adaptation. Unfortunately, mitigation is not going to do it all, And my fear is that mitigation is going to be a little slow out there worldwide. Now, when the president was recently in China, they made a handshake deal that they would both look at 30% reduction by, I believe it was 2030, which is interesting because that's the EPA reg on power plants is already getting in place. The question is we've got to also look at transportation, look at industry, look at other places that are generating emissions. So how big can we open that up and what can we do with it? But I'm not optimistic with the new Congress and some other things that are going on. So adaptation, I think, is going to be our friend in the future because the climate, she's going to be changing. So it's a focus of the impacts of climate change, and it's methods to analyze, assess actions, describe what's going to happen, and then reduce your risk to these, reduce your vulnerability to climate change, increase your resiliency capacity of your environment, and then it's going to be different. What we do in Champaign is going to be different than what they do in Miami or what they do in Seattle. It's going to be different because the climate drivers are different. The climate impacts are different. I'll talk a little bit about these later. But adaptation depends on understanding and projecting the climate impacts. Now, there's some new reports out that come out this year giving regional impacts for climate change around the nation. We're in the Midwest. We do have some impacts, although I think impacts on us initially are going to be fairly moderate. We've seen some of them. We're going to get the increased rainfall, more flooding maybe, a few things like that. Maybe some hotter summers and some warmer winters. We'll see how that all plays out because winter's gotten a little fuzzy lately. I'm not quite sure where this is going with the polar vortex or whatever it is. Well, actually, the jet stream has moved south, so that's affecting our winter climate. So these average temperatures, these extremes in temperatures, precipitation, the intensity of precipitation, you know, how frequently are we going to get the 100-year storms? Are they going to be every 2 years? This type of thing. So those are all in there, and those are highly local and diverse, how those are going to be. And I don't include sea level rise, but places like Miami are already dealing with sea level rise. I asked the folks in New Jersey about sea level rise and Sandy. So these were the projections for the Midwest. Increased heat wave intensity and frequency, increased humidity, degraded air quality, reduced water quality, extreme rainfall events, and flooding. They have increased and they're going to get worse. That's our projection for the next 100 years here. Now, this is Don Wobel's famous picture here. This is Illinois in the summertime. The idea is that it's hard to imagine where you are, your climate changing. So think about the state moving. So this is 1961 to 1990. Well, that's history, okay? This is 2010 to 2029. Our climate may be more like southern Illinois, Kentucky. That's what the implication is here in the summertime. And this then, the yellow is a low emissions path. The red is a high emissions path. So we could be headed by 2099 looking something like East Texas. Okay? How many corn and soybeans do we raise in East Texas? Okay, so there's going to be some changes. So it's going to be interesting. So that's what we need to think about and think about how these affect us. So there's a process, just like there's a mitigation process to go through, there could be a climate adaptation planning process. So we're talking about identifying current and future hazards. Okay? The inventory of our infrastructure and our assets that are going to be impacted by these changes. So for us in Champaign, probably we need to think about our storm sewer system. We think about runoff. We think about maybe dry summers. How's that going to affect growing of agriculture? All these other aspects are going to come in. Develop, characterize your risk. What's my risk exposure to these? Okay. What strategies can I do to mitigate that risk? How do I coordinate all these different opportunities? How do I prioritize my strategies? And then how do I implement these strategies? And then go ahead and implement, then monitor and reassess. Like any other plan, it's going to be, you know, plan, do, check. and things are going to change over time. We're going to incorporate for some things, and some things are not going to be right. We're going to have to make some adjustments. So all these plans have to be flexible, but there is a process. We're only in the infancy of doing this as a nation. Some cities are looking at this. I've looked at a few climate action plans. I think Oakland is looking at, Berkeley is looking at adaptation for the San Francisco Bay Area, but most people haven't really started to look at adaptation yet, never mind implement adaptation issues. So this is a new forefront that we need to get with. Now, this is from New York City's plan. It's a way interesting way they characterized risk. Okay, so on the vertical axis, the magnitude of the consequence, okay, the impact of this climate consequence. And then on the x-axis, the likelihood of the impact on infrastructure over that asset's useful life. So low, medium, high, very high, low, medium, high. And then they put in the colored blocks is, okay, red, you need to develop a strategy and get on that one. Okay, amber, evaluate further, maybe develop some strategies, and then yellow, watch it. Let's keep an eye on this and see. So that's how they categorize their risks. So these are the things they really need. They'd say, well, high risk, high impact. You need to do something about them and soon. Now, setting your priorities. Well, you look at that risk priorities, but there's a couple other things. One is, what is it going to cost to implement that strategy? And the other one, how soon do I have to implement that strategy? How soon is this change going to impact me? So, low, medium, high, low, medium, high. You can imagine that things in the long term, I'm probably going to do here high impacts, low funding. I'm certainly going to do those. Okay, so low funding, high impact. I'm going to do these. Medium funding and high impact. I'm probably going to do those. Then I'm going to wait on the ones that have higher costs but are out farther in time and moderate. And then these long-term things I'm going to think about. They're high cost and they don't have a great impact. So that's kind of a way to focus on these things. It's kind of an interesting way to think about risks. So when you put a group together to think about adaptation, these are the things that they have to think about. Okay, we're going to have this problem. How are we going to solve it? What's it going to cost? How soon is it going to need to be done? And where can we get the resources from? So it's planning. But as you go through this process, you can also think about the benefits that you're going to achieve. I get a big kick out of politicians who always talk about how much it's going to cost to do these things, and I'm talking about maybe 1% of the GNP in a few years, but they forget the cost of climate change, which is probably already there and past that. Excuse me. So you have to think about the benefits, and there are benefits across the board, from greenhouse gas reductions, environmental benefits, air quality, water quality, waste, avoided mortality for public health, less heat island type of thing, atmospheric quality, energy savings, monetary savings, creating jobs through energy efficiency. All of these are benefits. Income, energy benefits, sure, looking at just reducing our impact and our emissions. Social things, environmental justice, economic justice, quality of life, behavioral change. There are things that we can do to adapt that will actually make us a healthier society. Try walking and riding a bike, these kinds of things that actually make us healthier, more vigorous, and better quality of life, and actually help the environment. So, and there are tools out there. I'm not going to go through these, but there are tools out there that help you quantify these things. So it's kind of an interesting thing that we can do. But there are limits to adaptation. Okay? There are some issues associated with it. There are physical, institutional, and economic constraints to adaptation. So what would be a physical constraint? Well, we've had a habit over the years of building levees on rivers that flood. What has that gotten us? Think about New Orleans for a minute, okay? We just lost New Orleans to a storm a few years ago, okay? Eventually, levees will be overtopped. And now you built the levee, everybody feels safe, you build a whole major city behind the levee, and boom, the levee gets breached. Okay. So was that a good thing? There's a physical limit to how high we can build a level. There's a physical limit to how high we can build a seawall. Okay? And we build seawalls, what's going to happen? We're going to develop right up to them, and then eventually they're going to be overtopped, and then you're going to lose that infrastructure. So, when we think about physical limits that we can do, how are we going to build for the 1,000-year flood? Are we going to build for the 100-year flood? What are we going to adapt to with our storm sewers, our infrastructure? So we need to think about physical limits. Institutional limits. Unfortunately, institutions have a lot of inertia, and they need to be involved in these things. They have customs, they have regulations, they have legal aspects. You can't do this or you can't do that. You can go crazy with that. There's constraints on adaptations. Time horizons can conflict. If we've got one of these expensive ones that we want to do, but it's not going to impact us for 50 years and we're going to pay for it the next 20 years, is that going to work? Are people going to vote for that? Are they going to send a bond for that? No, probably not. So think about these horizons and how they can conflict with financing. And maladaptive things, levees, seawalls, those are maladaptive things. You're just making trouble down the line. The Corps of Engineers did a study about 30 years ago. They finally figured out instead of building levees and dams, buy the land and let it flood. It's the cheapest option. But that doesn't get enough pork into the districts. So Congress still has them with revetment fleets and building levees and maintaining levees and all these other kinds of things. But, buy the land and let it flood. That works. Okay? So adaptation plans need to address these limitations. And unfortunately, it's truth that neither adaptation nor mitigation alone or probably together will avoid all the problems that we're probably coming down the pike. So they can complement one another. Things that you can do to mitigate also can be adaptation. And I'll show you some of these. Okay? And both must be addressed. Mitigation alone isn't the end game. You can't just stop, putting out emissions because we've already embodied a lot of climate change into the earth. It's going to come. The oceans have warmed, all those things. Looks like probably the northern ice cap is in irrevocable melting. Very soon, this Antarctic ice caps are going to go into irrevocable melting. It may take them a century or two to do it, but we're going to pass the tipping point. So some synergies, a couple of examples of synergies here. Energy. So we want to mitigate our emissions, right? We want to reduce our emissions by expanding the use of renewables. What does that do for adaptation? Well, it puts in distributed generation, we call it. It's more robust. It's more local. It doesn't rely on the power lines to get you your energy. It's on the roof of your building, all these types of things. So you have a more robust, less brittle power system by using renewable resources. Solar, wind, biogas, landfill methane, all these things can make you feel. We want to improve the efficiency of our energy and water delivery systems. Well, does that also buy us some adaptation? Sure it does. We release capacity on the grid, makes it more resilient, makes it less problematic to outages. We won't have a failure by increasing demands. And you notice through these things, they assume we're going to have a lot of problems with the power grid in the future. These are from Italy, by the way. Oops, there's water. Food production. Okay, a mitigation may be, encourage local food production. Go local, more sustainable. Well, does that also? So we reduce the transportation cost of fuel. How far does the average mouthful of food go? 1,500 miles. That's the average mouthful of food in the U.S., 1,500 miles. So take some diesel fuel to do that. Okay? So if you do this, you also reduce your dependency on a centralized food system. Here again, you're more robust, you're more resilient when you have distributed sources of food, where you can get it locally and you can get it from far away. So you make it more resilient. Green building strategies. Certainly reduce our emissions by cutting energy use in our buildings so making better buildings. There's less demand on the grid again, that type of thing. Green building techniques, more insulation, taking account of more site issues, using native vegetation, all these kinds of things. They all help with adaptation because they are native and we have better building standards. We also want to increase our building standards to take care of things like climate change. But a better insulated building will better withstand harder weather, that type of thing. The other thing is if we go to natural lighting and better insulation, better systems in our building, when the power goes away, we'll be more readily can kind of ride through those types of things. Water. We want to reduce our emissions by reducing water, less energy, water, and wastewater use. Less energy required for treating and transporting water and treating wastewater. Any idea how much energy we put into this water and wastewater around here? Probably 5% of our electricity, somewhere in that range. Okay? You can figure 7% of your electricity is into the municipal infrastructure. The other bit is street lighting and some other things, and traffic lights and those types of things. California spends 25% of their energy moving water. Okay, 25% of their electricity. So conservation of water can be a good thing because you're saving it on both ends. You don't have to make it and you don't have to treat it. So it's an adaptation strategy, then you're demanding less on the aquifers, less on the resources. And we're starting to see some issues in Illinois. Decatur has trouble lasting through the year now with Lake Decatur in their water supplies. Chicago is having problems. So those are all there today. Smart growth strategies. There's a whole slate of these things that we can look at and how we address these issues. So higher density development, infill development, all these things, it makes you more resilient. Urban forestry, all these things can come into the picture and make you more adaptable, make it easier, more efficient to move around, make mass transit more viable, make pedestrian and bicycle flow more viable. All of these come from how we develop our urban infrastructure. Those are all kind of combined techniques. This is a picture from Philadelphia. And when you look at these, they're kind of like a Venn diagram. So you got mitigation activities that are pure mitigation here, and you got adaptation activities here. And what do you see here? These are things, you know, greenhouse gases, reducing energy, using GreenWorks, which is using natural ways to reduce energy. Over here, pure adaptation, clean water, rain gardens, things, stream restoration, get healthy Philly, you know, walking, biking, these types of things, resilient infrastructure, and then you get the ones in the middle. So things that have an impact on both. 1 million trees reduces your greenhouse effect, reduces your cooling loads at the same time, reduces your energy consumption, that type of thing. Vehicle miles traveled, bicycle commuting, hybrid diesel buses, all those span solar, PV. So that's all in the city plan where they're looking at those things. And you need to be flexible. On this chart, the blue fuzzy line here, that's kind of your maximum tolerable risk. So the blue line is, you know, business as usual. Here we go. Very shortly in time, our risk is going to exceed what we can tolerate. Okay? So if we have a rigid adaptation standard with mitigation, we can push it out a little bit. But it turns out we need to do some flexible adaptation. So if we get more flexible with our adaptation and can change as we go, we can expand that out to more decades. And then maybe the final solution to stay under the envelope of risk is to have flexible adaptation with mitigation. So we need both sides of that coin. That's the way it's going to go. So there are benefits associated with this. Just going through the process gets people aware and involved, and they can participate in these things. We can get a community consensus, see how we want to address these things. We can think about funding and get people and NGOs motivated and interested in this process. So the planning process. Cities are doing this first. National governments aren't really addressing this too much worldwide. And you can see cities all over the world are setting their own greenhouse gas emission goals. In the U.S., Europe, Asia, Australia. This one has got a, you know, almost net zero city, Melbourne, all the way down to maybe people who want to reduce their energy 20 or 30%. It varies around. So cities are taking the lead. Hopefully they'll now take the lead on adaptation. There are things you can do in your municipalities to address these things. You know, do some planning, incorporate those into your sustainability actions, mandated green building, adopt the latest codes for infrastructure and buildings, incentives and requirements to push people in the right direction. We need to do more with carrots than sticks, I think, on some of these things. Citing ordinances, guaranteeing people solar access, these types of things. We haven't even started to address these. I'm pretty sure if I put a solar system on my house, there would be somebody complain about it and write to the homeowners association. They'd probably come and tell me to take it off. So we need laws that say we can do smart things, okay, not dumb things. Okay? So requirements for renewables, green landscaping, all these things, all elements of new construction. We need to push in that direction. Okay? So both mitigation and adaptation are the keys to our long-term strategy. Okay? Sustainability plans must start to incorporate these things and be in that bigger picture. And we need to assess our local, current, and future impacts and respond accordingly. It's just what we have to do. The United States is currently experiencing impacts that require adaptation now. We need to adapt now. Southern Florida, they're getting seawater intrusion into the freshwater wells. They're getting flooding of parking lot seasons, that type of thing. They've already got sea level rise issues. Here we've got cities around here with flooding issues. Things that are going to increase as we go through the century and get worse. We need to find out what they are, plan our risk, figure out how to avoid them, and incorporate those plans and move forward. So the current and projected changes in weather is what we need to address. So basically, we need to take this sustainability planning that we do and kind of put it in that loop of climate change. I have some references on the last few slides, but I'm not going to go through those. They're just there for people who want to download the slides. And, of course, we can save the planet for nothing. I think that's a good idea anyway. Create more jobs, create better lives. Okay, I think I kind of ran long-winded. Questions?
So do we have questions from the audience here?
I think it's I like this presentation, and I'm a graduate student from the Department of Geography, so I have two questions. The first one is, I noticed that you didn't mention anything about nuclear energy in the mitigation of climate change. What's the reason for that? And the second question is, what do you think is the relationship between developing and developed countries in the mitigation and adaptation of climate change? Do you think the principle of common but differentiated responsibility is still the case, or should that be changed?
The second one's much more complex than the first one. The first one, I actually did have nuclear energy on one of my slides. I just forgot to mention it. I do believe nuclear power is part of the answer to this. The only trouble is the way we currently design and build and have a throwaway fuel cycle is not the best solution. The other factor with nuclear industry is that we still can't seem to build them on time, on budget. They're building a new one in Finland that's delayed years and years, and it's now twice the cost of originally planned. We've got 4 new nuclear power plants under construction in the U.S. We'll see how those meet their budgets. But we do have as a plan in the U.S. to build at least a half a dozen new power plants that will get guaranteed loans and incentives. That's out there. So I hope to see more nuclear power. And with ComEd making noises about shutting down their nuclear power plants that we have in Illinois, it doesn't make sense to me. I don't know how you can lose money at a penny a kilowatt hour. But the problem is they say they are losing money on those nuclear power plants. I'll see how they can do it. As far as responsibility for the global issues associated with climate change, I think that was what you're alluding to. I'm not sure what the solution is going to be. Obviously, we need some sort of contraction and convergence as far as wealth and income go in the world. How we use energy, that has to be more equitably spread out through the world. I tend to be sometimes a techno-optimist that we will eventually invent new, more benign energy sources and get them promulgated throughout the world, because poverty is a big issue, and many of the developing nations are the least equipped to deal with issues of climate change, and they're going to be some of them the most impacted as sea level rise. You know, the Pacific Islands, that type of thing. It's a major issue. What do we owe them? You know, we in the U.S. who have this legacy of emissions that goes back, you know, at least to the industrial age, where, you know, Europe all knit together is not quite as bad as we are, but it's getting there. I don't know. It remains to be seen how these are going to play out. There's probably going to have to be some treaties and things worked out, but we can't seem to get together worldwide on a plan to address mitigation, never mind adaptation and some of these other things. And right now, it just kind of falls on these nations to sort of suck it up. You know, what are you going to do? I don't know. But there certainly are going to be islands that go underwater. You know, I've been to the Marshall Islands. You know, the island is this high, 3 feet. That's what you got. And when you hit 3 feet, you're underwater. You know, so.
We'll go to this next question.
Yes, Dan. I enjoyed your presentation. Just one of the issues that you mentioned, the causes of this climate change, was the population increase in the last 5,000 years. And the population keeps growing. I mean, in the mitigation, is there any plan for reducing population in the world, or as a way to reduce? I mean,
that's a good idea. You know, as part of mitigation, till we look at population. Hopefully, as we get smarter and think about mitigation, those things, we start to think about our own population and start to mitigate. You know, mitigation for that starts at home. But you know, many people in the U.S. would have zero population if we didn't have immigration, and all of Western Europe, yeah, we are less than 2.1, yeah, without immigration. The Europe is shrinking, Russia is shrinking, a lot of nations in the world are shrinking. You know, we were talking about world population maybe peaking around 9.5 billion. Now, I read something recently that scared me a bit. They said that in Africa, you know, the efforts to reduce fertility, they've gone from 6.5 children per woman down to 4.5, and then it just stopped. And the hope was to get down to, you know, 2.1, something like that. So in Africa, that has stopped. I don't know what progress we're going to make. Africa has many failed states. You know, there's a lot of turmoil going on in there. You know, well, there's a lot of failed states around the world now. I mean, the whole Mideast to me is in a failed state status. So I don't know what we can do. That's certainly world population is a thing. But it makes sense. You know, there's an old equation. We used to have I equals PAT. Impact is population times affluence times technology. And you can intervene in any one of those to reduce that impact, but population is the tough nut to crack, I think. Yeah. Affluence we can deal with, and technology we deal with, and those are all in that mitigation loop that we saw.
Any other questions here in the audience? Or Robert, do you have any online? A question in the back here? This will be our last question then.
Have there been any serious discussions about creating payment programs for farmers to retire certain farmland for carbon sequestration? And what do you think about that, the viability of that concept, or should farmers be doing more on their own to reduce their own carbon emissions and their nitrous oxide emissions?
Well, yeah, I think agriculture is a big emitter. You saw it on some of the graphs. 7% of our greenhouse gases are nitrous oxide. Another maybe 8 or 10% is from CO2 from farming. Certainly, I think hopefully most of the farmers will be brought to the table understanding that it's waste. We can just get the good Puritan ethic in them that waste not, want not, and so much fertilizer and so much of these goods, it's just a waste of their money. And they are getting higher technology and looking at that and looking at a more targeted application of these pesticides and all these products on their land. Yeah, I would encourage some sort of soil conservation bank and get that back in. I think we do have some dichotomies in our nation between price supports for crops and these types of things, and it's encouraging growing more, that type of thing. I think we do have room to move in those arenas, and I think agriculture certainly has an opportunity to increase their soil carbon and some other things in some other areas. I would like to see more movement in that direction. I would like to see more afforestation too, and reforestation going on. People don't realize if I almost used a slide. It was a whole big thing of all these squares of all these environmental issues, and everyone had I think 2 had an arrow going sideways, and everything else had an arrow going down except for one thing on the whole chart. Temperate forests are going up. And if I go back to where I was a child in New England, and I used to go out behind my house, it was all fields with stone walls around them. Now it's all forest with stone walls around them. So we are reforesting in the temperate zone. Unfortunately, the boreal zone has taken a hit with climate change and the